Welcome to Understanding Wildfire with Professor Monks. Today's topic, Fire and Climate Change. Back in an earlier lesson, we identified weather as one of the three parts of the fire environment triangle. Weather is the short-term conditions of the atmosphere, comprising features like temperature, wind, humidity, and precipitation. When we take an average of the weather over a longer time period, we get climate, the long-term average condition of the atmosphere. The climate of a place tells you what kind of weather you can reasonably expect over the course of the year. But you've probably heard that our climate is changing. The average conditions of our atmosphere are shifting. The most basic manifestation of climate change is global warming. While the day-to-day weather has its ups and downs, on average the world is getting hotter. We've increased by about half a degree Celsius over the last century, and scientists predict we may warm by another 2 or 3 degrees over the coming century. That may not seem like much, but it was only a few degrees drop in average temperatures during the last ice age that buried most of what's now Canada and the northern United States under several kilometers of ice. We call the current changes in the climate anthropogenic, from the Greek roots anthropos, meaning human, and genesis, meaning origin. That is, it's climate change that has its origin or cause in human activities. Understanding how we are changing our climate requires a little bit of physics. The temperature of an object depends on the balance of energy coming in and energy going out. For the Earth, the energy coming in is light from the sun. Sunlight is mostly what we call shortwave radiation. That is, the distance from one peak of a solar ray to the next peak is fairly short, on the order of 0.0005 millimeters. Some of that energy is reflected back out into space by the Earth. The rest is absorbed by the Earth. After absorbing that energy, the Earth radiates it back out. The Earth's radiation is long-wave radiation, on the order of 1 millimeter wavelength, which we sense as heat. If we plug some numbers into a basic energy balance model, the amount of radiation from the sun, the reflectivity of the Earth, the amount of radiation that we expect the Earth to emit, it tells us that the average surface temperature of the Earth should be about minus 18 degrees Celsius. That's way colder than the actual temperature of 15 degrees Celsius, so there must be another factor at play. That additional factor is the greenhouse effect. Most of the Earth's atmosphere is made up of nitrogen, oxygen, and argon. These are simple gases that are transparent to most kinds of radiation. Both the incoming shortwave radiation from the sun and the outgoing longwave radiation from the Earth pass right through them. But there are small amounts, less than 1%, of more complex gases like carbon dioxide, methane, water vapor, and nitrous oxide in our atmosphere. These gases let shortwave radiation pass right through, but when hit by longwave radiation, they absorb it. Then they radiate it back out, sending some of it back down to the Earth's surface, where it gets absorbed again. These gases keep all the energy from being radiated back out into space right away. And with more energy in circulation, the Earth's temperature goes up. We call these gases greenhouse gases, because the way they trap energy on the Earth is similar to the way that the glass in a greenhouse traps energy. The natural greenhouse effect on Earth makes the planet habitable. Without it, the Earth would be too cold for life. But human activities are increasing the amount of greenhouse gases in the atmosphere, and thus enhancing the greenhouse effect. This causes the Earth's overall temperature to rise. For the purposes of this lesson, we're going to focus on the most important anthropogenic greenhouse gas, carbon dioxide, or CO2. You'll remember that CO2 is one of the major byproducts of burning. When we burn plants, we're just closing the loop on a cycle. CO2 in the atmosphere is taken in by plants during photosynthesis, then returned to the atmosphere by burning. So the carbon can be found either in the atmosphere in the form of CO2, where it acts as a greenhouse gas, or in the bodies of plants, where it has no impact on the climate. This means that one form of anthropogenic climate change can occur if we burn more or less, changing the percentage of the Earth's carbon that is in the form of atmospheric CO2. Today, increasing areas of tropical forest in the Amazon, as well as Africa and Southeast Asia, are being cut down and burned. This adds CO2 to the atmosphere, enhancing the greenhouse effect. And because these areas are not allowed to grow back into forests, for example, if they're turned into cattle pastures or soybean fields, that carbon is not taken back out of the atmosphere. But current climate change goes beyond what can be caused by changing the burning of plants. We're also adding new carbon to the system. This carbon comes from the burning of another fuel, fossil fuels, that is, coal, oil, and natural gas. Fossil fuels had their origins in photosynthesis hundreds of millions of years ago. Plants grew, building up carbon in their bodies, and then were buried underground. Millions and millions of years of heat and pressure transformed them into coal, oil, and natural gas. They hung out underground, not participating in the carbon cycle until the mid-1800s. At that point in history, the Industrial Revolution created an enormous demand for energy to power the new machines that were being created. Fossil fuels provided a convenient energy source, but when these fuels are burned, they put carbon dioxide into the atmosphere. Before industrialization, the atmosphere contained about 280 parts per million of CO2. Today, the amount of CO2 has gone above 400 parts per million, and is well on its way to doubling if current policies continue. Climate scientists estimate that a doubling of CO2 in the atmosphere would cause a global temperature rise of something like 3 degrees Celsius. It's important to remember, of course, that this temperature increase is not even across the whole Earth. While everywhere is expected to get warmer, the increase is greater near the poles. Climate is more than just temperature. Precipitation is another important element to climate, and that's changing too. By putting more energy into the Earth, we are generally increasing the differences between wet and dry areas. That is, areas of the Earth that are already rainy can expect even more rain, and areas that are already dry can expect to get even drier. Both temperature and precipitation are expected to have significant impacts on wildfire. The first effect of climate change on wildfire is straightforward. If it's hotter, there will be more and more intense wildfires. Warmer temperatures make it easier for fires to ignite new fuel and harder for firefighters to stop them. The effects of increasing temperature can be partially offset if a place gets wetter. Humidity and precipitation inhibit the spread of fires. But many places, such as Australia and the western USA, are expected to get drier. Drought makes fires more intense because dry fuel burns more easily. Many parts of the world will get a climate change double whammy of hotter and drier conditions. If climate change makes fires more frequent and more intense, that's clearly bad news for people whose homes lie in the fire's path. It may also be bad news for ecosystems, as the new fire regime lies outside the parameters of the old fire regime the organisms are adapted to. Existing species may be driven toward extinction by the new fire regime. Meanwhile, new invasive species might move in if the new fire regime is suitable for them. This could, for example, result in a shift from a forest, whose trees need a longer fire interval to mature, to a grassland, since grasses thrive with higher frequency fire. Another effect of climate change is on the length of the fire season. Recall that the seasonality of fire can be just as crucial as its frequency or intensity. Most areas have a fire season, a period during the year when fires can be expected. Outside of the fire season, it's too cold or too wet for many fires to occur. But climate change is lengthening fire seasons. Fires start earlier in the year and continue later in the year than they had in the past. This is disruptive to ecosystems, as fires may now be occurring in different stages of organisms' growth and reproductive cycles. It also complicates fire management. A longer fire season is more expensive in terms of firefighter wages and equipment, and reduces the periods of time during which pursual loads. It also makes it harder to share resources. For example, Australian fire crews often come to help fight particularly big fires in the US and vice versa because the country's fire seasons are different. But lengthening fire seasons mean that Australian firefighters may still be needed at home when the US fire season gets going, and vice versa. Recent major wildfires in California, the Amazon, and Australia have led to big debates about the role of climate change in driving them. Determining how much climate change contributed to a phenomenon like wildfire or a drought is known by climate scientists as attribution. Attribution studies are complex and involve a lot of different variables and assumptions. For example, one recent study concluded that the massive wildfires in Australia in 2019 and 2020 were made 30% worse by climate change. Remember that climate is the long-term average atmospheric conditions. Because weather conditions vary considerably from day to day and year to year, it's always possible that a major individual event, such as a large wildfire, or a hurricane or period of drought, might have happened even in the absence of climate change. But climate change will make major events like these more likely, and so they'll happen more often. So rather than saying, this fire was caused by climate change, it's usually more accurate to say, this fire is the kind of thing that's becoming more common due to climate change. And that's reason enough to be concerned about the effects of climate change on fire.